Hello everyone. In this video we are going to discuss magnets and magnetism. Some of the basic properties of magnet we are going to discuss, and further we are also going to discuss some of the very important terms which are used in magnetism. So go through the video very properly and see to it after you finish the video, if there is any doubt then you must post me the doubt. Okay. So let us first discuss the definition of a magnet. A magnet is a material that has both attractive and directive properties. Like by attractive property we mean that when we take a magnet and we bring some magnetic material near it, all the magnetic materials will be attracted towards the magnet. Whether it is the north pole of the magnet or it is the south pole of the magnet, that doesn't decide whether it will be attracted or repelled. It is always attracted. Okay. Whenever we have a magnetic material, whether you place it near the north pole or you place it near the south pole, in both the cases there will be attraction only. Okay. Now further, here a magnet has a directive properties also. That is, when we suspend a magnet freely, then it aligns itself in the direction of the Earth's north and south. You must have seen magnetic needles which are generally provided in watches also. You will find that it always aligns itself in the direction of Earth's north-south. So that is known as the directive properties. That means whenever it is freely suspended, it aligns itself in the direction of north-south. Now, it attracts small pieces of iron, nickel, cobalt. These are the magnetic materials. Okay, so whenever the magnetic material is placed near a magnet, these magnetic materials are attracted. This property of attraction is also known as magnetism. See, when we consider some of the magnetic materials, those magnetic material doesn't have any magnetic property, but when they are brought near a magnet, then the magnetic property is induced in such material like iron, nickel, cobalt. These are called magnetic material, and this phenomena, this attraction of these magnetic materials is known as magnetism. So I hope this is clear. Now there are some artificial magnets that we are going to discuss here. See, first is the bar magnet. The bar magnet is made up of steel, and a process is done in which it develops two separate poles. One is the south pole, another is the north pole, and this is a kind of artificial magnet that is in the shape of a bar, which one end has a north pole, another end has a south pole. Okay. Now another example of artificial magnet is the magnetic needle, which is suspended such that it can move freely in the horizontal plane. So if it moves freely in the horizontal plane, it always aligns itself in the Earth's north-south direction. So this is magnetic needle. Then another example of artificial magnet is a horseshoe magnet. You must have seen the horseshoe, which is a iron nail in the shape as shown here. So that's why it is called a horseshoe magnet, which has a north pole and a south pole. Another type of artificial magnet is ball-ended magnet. Two balls are connected to the metallic ends, and which are actually in the form of magnetic poles. One is the south pole, another is the north pole. Okay, so these are the examples of artificial magnet. Now some of the basic properties of magnet we will discuss here. The first property is attractive property. Here you need to understand that suppose we take a bar magnet here. Okay. Now we sprinkle iron fillings over it. So what will happen? We will see that when the iron fillings are sprinkled over it, all the iron fillings, whether it is near the North Pole or near the South Pole, will be attracted towards the magnetic bar or the bar magnet. So the magnet has a property of attracting magnetic materials. Here we have considered iron fillings. So these are the magnetic material which are attracted by the magnet. Okay. Now next is directive property. As I have already discussed now, a directive property means when a magnet is freely suspended. Okay? When it is freely suspended, then we find that it aligns itself in the direction of north-south. Okay? And when it aligns itself in the direction of north-south, automatically, if it is free to move in the horizontal plane, then this property is known as the directive property of the magnet. Okay, so these are the two properties: attractive property, directive property. Next, the third one is like pole repel, whereas the unlike pole attract each other. That we always know. We'll see the diagram here. You can see here the north and north, if they are brought together, then you will find that they repels each other. Okay, so when there is like pole, so they will be repelling each other. As in the case of charges, like charges repel each other, in the same way like poles also repel each other. Okay? But when we consider the unlike poles, like you can see here, if the south pole is brought near the north pole of another magnet, then there will be an attraction. Okay. So this attraction shows that the unlike poles attract each other. Same as in the case of charges, positive and negative charges attracts each other. So I hope this point is also clear. Now the next is magnetic poles always exist in pair. This is very, very important. Suppose you take a magnet. Suppose you see the first magnet which is taken here. It is a long magnet, bar magnet, which has a north pole and a south pole. Now suppose you wish to break it in between. So you have broken it, but still then when you broke it, two new magnets are created which have north pole and south pole, and again the another one also have the north pole and south pole. Like in the first bar you see north pole and south pole, two poles are there, one is the north pole and the south pole. And if you wish to break it and you think that you will be separating the north and the south pole, then it is not possible. If there is a north pole, then there is a south pole also. Okay, and you can break it n number of times, any number of times, and every time, however small the segment be, always there will be a north pole and a south pole. Okay. So this is the difference between a magnet and when we consider charges. Electric charges can exist separately. That is, electric monopoles are possible. That is, a positive charge can exist separately, a negative charge can exist separately. But magnetic monopoles are not possible. They always exist in pair. If there is a north pole, you will find a south pole also. If there is a south pole, then in the same magnet you will have a north pole also. Okay? So always remember that poles always exist in pairs. Okay? You cannot have different single north or single south separately. Okay? So these are the properties. One more property we will discuss, that is the magnetic induction. Magnetic induction means when we bring the magnetic material near a magnet, then the magnetic properties are induced in the magnetic material, and that is known as magnetic induction. Like as we describe here, a magnet induces magnetism in the magnetic substance placed near it. This phenomena is called magnetic induction. The magnetic materials like iron, nickel, cobalt, steel, all these magnetic material, they don't show any magnetism. Like if iron rod is there, and if you take another iron rod near it, it will neither show attraction nor it will show any repulsion. That means it doesn't show any magnetic property. But when you take that iron rod near a magnet, then that iron rod will also start behaving as a magnet. And if you take another iron rod near the first one, which is present in the magnetic field, then it will either it will attract the iron rod. So magnetic property is gained by magnetic material when it is brought in a magnetic field near a magnet. This phenomena of induction of magnetic property in a magnetic material when it is taken near a magnet is known as magnetic induction. Okay, so I hope this is clear. Now we will discuss some of the terms which are used in magnetism. Okay, now first is magnetic field. Suppose we have a magnet, a bar magnet is there, then the space surrounding it, where when any other magnet is brought, will experience a force of either attraction or repulsion. That space around the magnet within which its influence can be experienced is known as magnetic field. Any magnet, the region surrounding it where its influence can be felt is known as the magnetic field of the magnet. Now, magnetic field can be uniform also, it can be non-uniform also. Here we will discuss the uniform magnetic field and we will see some of the examples. A magnetic field in a region is said to be uniform if it has same magnitude and same direction at all points of that region. Okay, suppose a region is given and you are said that there is a uniform magnetic field. It means the magnetic field will have same magnitude and direction also at that region. Okay, magnetic field is a vector quantity, it has a magnitude as well as direction also. See here, the cross sign represents the magnetic field is in the inward direction. The dot sign represents the magnetic field in the outward direction, and you can see the position of the cross, they are equidistant from each other, showing that the field is uniform, that is the magnetic field is uniform. If you want to show horizontal magnetic field on the plane of the paper, then the parallel arrows equidistant from each other represents uniform magnetic field in the horizontal direction. Okay. Now magnetic poles. Magnetic poles are the region of apparently concentrated magnetic field in a magnet where magnetic attraction is maximum. Okay, that is when we take a magnet, then there are points where the attraction for the magnetic material is maximum. Those points are known as magnetic poles, that is north and the south pole. Magnetic axis, you can see in the diagram the line joining the north and the south pole is known as the magnetic axis. Another axis which cuts is perpendicularly at the midpoint is known as magnetic equator. Okay. Here the definition of magnetic equator, you can see the line passing through the center of the magnet and at right angle to the magnetic axis is called magnetic equator of the magnet. Okay. Then magnetic length. This you need to understand. Suppose a magnet is provided where the north pole and the south pole is not exactly at the end but near the end. So the magnetic length is the distance between the north and the south pole of the magnet. Whereas the geometrical length of the magnet is slightly greater than the magnetic length. If you compare them, like the magnetic length divided by the geographical length, so geographical length is a little bit more than the magnetic length, the ratio is 0.84. Okay, so you need to understand the magnetic length is not exactly the geometrical length. Geometrical length is slightly greater than the magnetic length of the magnet. So I hope this video is very clear to you, but still then if there is any doubt, please post me the doubt. Thank you.